let's take a look now at example number 1, and let's try to go ahead and conduct a full test. This is going to be the same example that was talked about in the opening motivation, but let's recap. Suppose a company has 3 manufacturing plants, and company officials want to determine whether there's a difference in the average age of workers at the 3 locations. The following data are ages of 5 randomly selected workers at each of the plants. Assume the ages at the company are normally distributed, and the population variances for each one of the plants are equal. So this last sentence here is some excess information. We'll see what we're going to do with this in a moment. But we can start by writing down our different hypotheses. Notice here that I have 3 different plants. I just have them labeled as plant 1, plant 2, and plant 3. Well, that makes it pretty easy to write down my null hypothesis, which would claim that the averages for all employees at the 3 plants are going to be equal. So mean 1, mean 2, and mean 3 are all the same. Now I'm going to be squaring this off against the alternative hypothesis, which remember is always going to be that at least one average is different from the others. Okay, so these are my 2 hypotheses. Well, let's go ahead then and jump down to our test statistic. Remember here I'm going to start by listing out my sample evidence. And actually here, in order to do that, I don't really have a lot to write down because all the information is already listed here. So I'm going to go ahead and I'm going to enter that data into lists. Notice here I'm saying lists as in plural. So I'm going to go to my calculator, going to go to stat, going to go to edit. If I have anything that's already in some lists, I'm just going to go ahead, I'm going to clear that stuff out. Oops. And I'm going to get ready to list out 3 different lists of information here. So I have my first set of data. That's my ages for the employees at plant number 1. Then the ages for employees at plant number 2. And then finally the ones for plant number 3. Once I have all of these inserted, I'm pretty much done with my evidence. Well, now we're going to go ahead and move on to our checks. So let's see. Checks for this, remember, were written down on the previous page, but you can also find them on the formula sheet. We'll see that the first check is a pretty standard one, which is my data obtained from random samples? And there's not really much to write here. I'm just going to go ahead and check that off. Yes, I'm told that I had, in the problem, randomly selected workers, so that seems to be good. Check number 2. Data comes from a normal population. Well, I can see now why it was helpful to say that the ages here were normally distributed. Remember, if I wasn't told that, I could actually take this raw data and put it into a list and create a normal probability plot to go ahead and actually determine if I thought that this was a reasonable assumption. But since I'm just told this here, I'll just check this off. For number 3, I need to know that the variances of the populations are actually equal. Now, this here is partially what makes an ANOVA test a little bit kind of strange. We've never talked about calculating variances directly, but we are told here in this question to assume the population variances are equal. Now, in the real world, we would actually have to do an entirely separate set of hypothesis tests to see if this is a reasonable belief, where we can actually test to see if population variances are believable or possibly equal. Is it reasonable to believe that? Now that's a separate hypothesis test and one that we're not going to cover here in this class. If you're interested though in the details of that, please by all means let me know and I'd be happy to talk with you about it. So I have all of my checks that are met here, and so now I would actually be able to go ahead and run an ANOVA test on my calculator and get ready to record my test statistic, which remember in this case is going to be given by a letter capital F. So let's go to the calculator and see what we end up with here. So on the calculator, I'm going to go to Stat, I'm going to go to Tests, and I'm going to hit the up arrow. Actually, the very last item I should see on my calculator is this ANOVA test. Now if I click this, I'm going to go ahead and see that I can click second and then number 1 to pull in list 1, and I have to offset my lists by clicking on this comma button, which is right above the 7. Since I had 3 lists, I have to enter all of those. Now when I go ahead and I hit enter, you can see here that I get a whole bunch of values, but right at the top is my value of F, 39.7143. So I'm going to go ahead and write that down. Again, that was 39.7143. Okay, well, I'm going to go ahead now and analyze my data. So I'm going to go ahead and draw out a nice F distribution. Remember, it looks like this and has a big tail over on the side. Now, I know that my value is at 39, and over here is kind of like where the origin would be, so that's going to be 0. So my value of 39 is way, way out here somewhere, 39.7143. And remember that this is always going to be a right-tailed test. So I have this. This here is going to represent my p-value. And I know that I can set this up as the probability that I would calculate an f that is greater than 39.7143. Now, it's actually possible to compute this value directly using an F distribution, which you could find on your calculator underneath the distributions menu. Again, though, what we have here is that the p-value is already being given to us. Ooh, but notice again, I have something strange happening with this p-value. Notice I should not write down the value 5.112. That would say that like my probability is like 500%. That's not even possible. But if I ever see my p-value starting with something that is not 0, I better read all the way to the end and notice, oh, scientific notation. I need 6 zeros before my actual remainder of the value starts. So that means here that my p-value is being given as 0.00000. Notice I have 5 zeros right now. Now I'm at 6 total zeros. And then my value of like 51012. Now, of course, we can always just round this off to 4 places. And so if I look at just the first 4 places that I have here, maybe the 5th one to see if I should round anything up, I can easily see here, all right, well, this is pretty much 0. The chances of getting this value for f just by dumb luck, if h0 is true, is like next to impossible. And so I can see here I definitely have a very rare sample if all the averages are equal. And so I would go ahead and choose to reject h0. Again, my value of alpha here on this question probably doesn't even matter, but I think it should be 5%. Notice again, since it's not listed up here, it's implied that it's going to be a 5% level of significance. So we're going to go ahead here and reject h0, and then write out our conclusion in the same way that we always do. So we'll say it is very rare to get a, or let me rewrite that, to get an f value of 39.7143 by chance if all 3 averages are equal. This is what the p-value tells us. It's really weird to see what we saw if h0 is true. And so then the second part of my conclusion here would be, therefore, we have enough evidence to believe that at least one of these averages is different from the others. Okay, there it is. Hopefully, again, you're starting to see the pattern here throughout all of the hypothesis tests that we've been doing. They're pretty much the same thing every time with the small minor variations here and there. There's nothing really different about what we did here. We had hypotheses, a test statistic, we drew our picture, we made the same sorts of interpretations that we always do. Now, I'm not going to go ahead and do the rest of the problems in this particular set of notes. I'm going to leave those as ones for you to practice, and that's what we would have done had we been in a class where we were meeting face-to-face for this section. So go ahead and try to practice those questions on your own. Shoot me emails if you have questions about them. And of course, remember that the solutions to all of those are posted up in the notes in Blackboard.